Today we're going to be learning about circumference and arc length for the first section, and the second section will be about area and area of the sector. So to start, we're going to first discuss circumference and arc length. Circumference is the distance around the circle. Both of these formulas, C equals 2 pi r or C equals pi d, is on your formula sheet. You don't need to memorize them, but you do need to know how to apply them. So we're going to go through these three examples. And we're going to use the diagram to find the indicated measure. If it's asking for circumference, I'm going to be leaving everything in terms of pi. For the first one, 16 inches is the diameter, so C equals pi d, we can use that one. And it's just simply 16 pi. And since it's circumference, we just can leave it in terms of inches. So that's the circumference of the first circle. The second one gives us the circumference, C equals 35 yards, and we're supposed to work backwards in the formula to find the radius. So for this one, 35 is our circumference. Set that equal to 2 pi r. To get r by itself, you need to divide by 2 pi. The radius for this circle can be 17.5 divided by pi, or if you divide out by pi, it should be about 5.57 yards. Either answer works. And for the last one, it's the circumference, and it gives you 4.5 centimeters, which is the radius. The C equals 2 pi and 4.5. And I'm going to leave this in terms of pi. The circumference of this would be 9 pi centimeters. Arc length is a fraction of the circle's circumference. So you're actually trying to find, like if you were going to be walking from point A to point B around the circle, there is a formula that you need to memorize. The arc length formula is not on your formula sheet. So different ways you can look to find the arc length or think about the arc length. The length is equal to the measure of arc AB. So you use the central angle, that measure divided by 360, because that's a fraction or a portion of your circle's measure, and we're multiplying that by 2 pi r, which is the circumference formula. So you can also think of the measure of arc AB over 360 times pi d, or lastly, it's just measure of arc AB over 360 times your circumference. So that formula does need to be memorized. So let's go ahead and work on some example problems with the arc length. First one we'll do together. It says, what is the length of arc BA? Leave your answers in terms of pi. So, for instance, the measure of the arc AB would be 100 degrees, all divided by 360, times 2 pi and your radius 3. Leaving it in terms of pi, it would be 100 times 6, the 2 times 3, over 360 pi. And when you simplify that in your calculator, or however you want to simplify it, you should get 5/3 pi. So that is the length from A to B of that circle. So go ahead and pause and try to find the length in terms of pi of the second circle. If you completed the formula and simplified correctly, you should have obtained the answer of 2/3 pi. Now for these three, it will give you part of the arc length, so it wants you to use the formula and work backwards to find different parts of it. So the first one is asking for the actual degree or the measure of the arc AB. So this would be points A and B. So 18.84 meters is your arc length. So set 18.84 equal to, we're trying to find the degree measure of AB over 360 times 2 pi and 9. So you're just going to have to solve that equation for x on the top. I would get rid of the 360 on the bottom first. You can do different methods to solve this equation. Multiply both sides by 360 and you get 6,782.4 equals 18 pi x. So now you're just going to be getting rid of the 18 pi, so divide out by 18 pi. And for the degree, once you put that on your calculator, you should get 119.94 for the degree of AB, that central angle right there. But the second one is asking for the radius, the same thing, 1.57 feet. Set that equal to 45 over 360 times 2 pi, and we're trying to find the radius x. So get rid of the 45 over 360 times 2 pi, and when you solve that equation, going through all your algebra work, you should get it to be about 1.99 feet for your radius. And the last one wants you to find the circumference. It gives you the arc length, and 200 degrees is that angle in the center there. So for this one, 41.87 should equal 200 over 360. And remember when I was writing that formula, you can multiply everything by C, the circumference. So we're going to solve for the circumference. So multiply by the reciprocal, the 360 over 200 on both sides. So your C, when you do that, you should obtain the answer of the circumference of 75.37, and that's in centimeters. So we'll just put the units there. All right, moving right along, the next section is area of circles and sectors. The area formula is listed right here. Area equals pi r squared. That one is also on your formula sheet. You do not need to memorize it. There is no formula with the diameter, so you do need to have your radius. So there are two samples. I'm going to keep the first one, the area, in terms of pi. So area equals pi and 5.2 squared. So when you plug that into your calculator, in keeping it in terms of pi, you should get the area to be 27.04 pi, and that would be inches, and since it's area, the units are squared. The second one is finding the radius, where they give you the area is 201 feet, so plug that in for the area. That equals pi r squared. So you need to divide out 201 divided by pi first. When you have that answer, it should be about 63.98, and you still have r squared, so you need to square root both sides. So your radius is going to be approximately 7.99 feet. All right, just like the arc length, we have a formula for the area of a sector, and the sector is a fraction of the circle's area. Or I tell you guys to think of like a piece of a pie or a piece of pizza. You're trying to find the area of that little section. Just like arc length, you have to have this one memorized. It is not on the formula sheet. It is very, very similar to the arc length. The area of the sector is the measure of the arc AB over 360. So there's that fraction out in front that is the same for arc length. But now, since we're trying to find a fraction of the circle's area, we're multiplying that by pi r squared, which is the area formula. So you can also think of this formula as the measure of arc AB over 360 times the area formula. So we're going to do a couple examples with that, and everything's going to be left in terms of pi, just like the arc length. It says find the areas of the sectors, leave your answers in terms of pi. We're first going to do the shaded region of the first circle. So the measure of the arc is 110 divided by 360 times pi and 21 squared. So the setup and the process to find it in terms of pi is the same thing as arc length. So go ahead and try to simplify and find the area of the shaded region first. And if you've done so correctly, you should have 539 over 4 pi, and that is millimeters squared. Now the unshaded, you're going to have to find the other arc. You can still use 21 as your radius, but now you're going to have to do 360 minus 110 to find the measure of that arc for the unshaded portion. which will be 250. So for the unshaded, 250 over 360 times pi and 21 squared again. So go ahead and do your algebra work, and if you have done so correctly, the unshaded area should be 1,225 over 4 pi millimeters squared in this area. So go ahead and pause and try to find the shaded and unshaded region of the second circle. After you have found the shaded region, you should have received 50 over 3 pi inches squared. And then the unshaded region would be 250 over 3 pi inches squared. All right, there are two other types where we're finding the area of the circle, and it would be very easy if they gave you the radius, but in both of these circles, they did not give you the radius. They gave you the central angle, and then they gave you the area of the shaded region, or the area of the unshaded region for the second circle. So, just like before with arc length, we can set 123.45, because that's the area of the sector, equal to 70 over 360, and we're trying to find the area. So A is going to be our variable, and we're just going to solve for A, which is multiplying both sides by the reciprocal of 360 over 70. When you do that, you should get the area of the circle to be 634.89 inches squared. Okay, for the second one, 39.52 is the unshaded area of the sector. That should equal 175 over 360 times your A. Multiplying by the reciprocal of that fraction, your area of this circle should be 81.298 inches squared. We have one last type of example to go through. It's finding the area of the shaded region, the unshaded region, when you have more than one shape involved in the problem. So the first one has two different circles, and we're going to find the area of the shaded region. So first, and we're going to leave both of these in terms of pi. You need to first find the total area of the entire shape, which would be area equals pi and 4 squared, because 4 is the radius of the entire circle. So that area will be 16 pi. The area of the smaller circle that we want to remove and not keep as our total area would be area equals pi and 2 squared, which that area will be 4 pi. And since both of them are in terms of pi, we could just do 16 pi minus 4 pi to obtain the area of the shaded region as 12 pi. Subtract out the 16 and 4. If you have a square and a circle, so a square is not in terms of pi, but we can still leave our answers in terms of pi. To find the area of the circle, the area of the square, area equals pi squared, which will be 4 squared, and the area of that entire square would be 16. But we need to remove the area of the circle, and if you notice, the radius is going to be 2/2 of the length of the side of the square. So area for the circle will be pi and 2 squared, which equals 4 pi. You cannot just subtract 16 minus 4 and get 12 pi again, because 16 is not in terms of pi, but if you were going to leave your answers in terms of pi, it would simply be 16 minus 4 pi. So that answer is in terms of pi, and that would be your final answer.